All right, guys, we'll start from the chain rule again.
Ma'am, I wanted to ask if we get marks for attending classes.
No, pardon? It is fine. Okay, we'll start from the chain rule again. But before we get there, I want you to remember these rules. We have the power rule. This means we are differentiating x to the power n, right? And if we differentiate this will give us n x to the power n minus 1. Okay, and again, this one, ex. Okay, this sign, it's a notation for differentiating. It just means you are differentiating the function inside. Okay, if we differentiate e to the power x, we get e to the power x, right? And again, we have something like this, the derivative of ln x. Here, we get 1 over x, right? Okay, here, n can be an element of real number, all right? Then we have, let me see. Okay. Just these ones for now. I will add if I forgot something. Okay. Instead, we are doing rule 9. A chain rule. Or it's called the function of the function. Okay, here for a chain rule, the chain rule says the derivative of y with respect to x is equal to the derivative of y with respect to u times the derivative of u with respect to x. Okay, we're differentiating y with respect to u, and then we multiply that with the derivative of u with respect to x. Okay. The reason I said you should remember these rules is because we're going to use them here on the chain rule. Okay. For a chain rule, will be, okay, we are given a function that is not easy differentiable. That's why you need to simplify that rule to be, so that you'll be able to apply these rules. Okay, in this course, we'll cover only these rules, right? Okay, for example, suppose you are given a function like this, y equals 2x plus, okay, 2x squared plus 15x plus 9 to the power 100, right? Okay, you see here we are given a function to the power 100, right? Like, for you to be able to solve, to differentiate this, you have to simplify this function first, right? Because, for example, if you have y equals maybe let me just say 2a plus b squared, right? You know that this, you can write this as 2a plus b times 2a plus b, and then you solve the brackets out. So if you solve these brackets, you'll have something like 4a squared plus b squared plus 4ab, right? You'll have something like this. Again, if you have to the, okay, you see, after simplifying this function, we can easily differentiate it because you can use the power rule, right? So again, if you have something like this, y equals a plus b to the power 3, you can simplify this as in a plus b times a plus b times a plus b. And then you simplify, you solve these, all the brackets, you multiply them to make it simple like this, right? But now, what if you have a bigger number? Are you going to multiply these brackets? Are you going to have 100 brackets to multiply, and then you simplify, and then you do the differentiation? Imagine you are writing a test, you know your exam is 2 hours 30 minutes. Then you first do these steps where you multiply all the 100 brackets. After multiplying them, then you do the differentiation. That will take you like an hour or even more. So instead of wasting time like that, right, you can just use the chain rule, right? Let's define this function. Okay, just write this function in such a way that you can be able to use all these 3 rules. 1, 2, 3. Okay. And you see, if you look at this function and you compare them to all these 3, you'll see that it's closer to this one. It's closer to this one, right? But the problem is here, we have only one variable to the power n. But here, we have a function to the power n, right? So what you can do is let this function to be one variable so that it would be in this form, right? Okay. Let's say we let that function to be u. So this means we have u equals 2x squared plus 15x plus 9. So if this whole function is u, this means we can write our y as u to the power 100 because we let all this function to be u. Okay, you see now this function it's in the form of this function. So it's easy for us to use this rule, to apply this rule here, right? But, okay, if we differentiate this function, since this is y, which is in the form, which is the function of u. That means if we differentiate this function, we'll have the derivative of y with respect to u, not with respect to x, and our function was given in terms of x, right? So this means here, if they say find the derivative of this function, since it is in terms of x, so that means they want dy over dx, meaning we are differentiating y with respect to x. But here, our function is in terms of u. So this means if we differentiate this function, we'll have dy over du, right? Which is not this function. Okay, but we can write dy over dx as in dy over du times du over dx. You are okay. First, before I get there, can write dy over dx as in dy over dx. Okay, dy over dx is the same thing as dy over dx. I can multiply this with 1, right? Anything multiply by 1, you'll get that thing. Like we are multiplying dy over dx with 1. So this means the answer is dy over dx, right? But you know, 2 over 2 is the same thing as 1, right? 4 over 4 is the same thing as 1, right? So this means du over du is the same thing as 1, right? So instead of writing this 1, let's substitute that 1 with du over du, because we know that du over du is equal to 1. Okay. So this means we have dy over dx times du over du, right? Okay. But we said it's not easy for us to find dy over dx from this function, because it will cost us time, right? But we introduced a new variable, which is u, right? And we said from this function we can find dy over du, right? So this means here we can have something like this. Okay. Without going back there, we can write this as dy du over dx du. And this is the same thing as dy over du times du over dx, right? The reason I'm writing this function, this term like this, it's because we said it's not easy for us to find this term, right? So let's try and find this. And then we have u, which is in terms of x. That means we can also find this term, right? And if we write them like this, This means we have dy over du times du over dx. And that is the chain rule. Right. So it means in this function, we can use a chain rule to find the derivative. Right. We said y is equal to u to the power 100. Okay. Here we can differentiate y with respect to u. If we differentiate y with respect to u, we use rule 1, the power rule. If we use rule 1 here, we'll have 100 u to the power 99 because you subtract 1. Right. And again, you have u equals to 2x squared plus 15 plus 9. 2x squared plus 15x plus 9. And if you differentiate this, differentiating u with respect to x, this is what you'll obtain. You apply power rule. You'll have 4x plus 15. And then you substitute them back here, and here. Okay. We said dy over dx is equal to dy over du times du over dx, right? This is our dy over du. Substitute it here. You'll have 100 u to the power 99, right? And this is du over dx. You substitute it here. So this means you'll have times 4x plus 15. Okay. This is the dy over dx. But remember, our function did not have u. We only introduced u for ourselves. So the next step is to put back the value of u. And we said u is equal to this function, 2x squared plus 15x plus 9. Okay, this means our final answer would be 100 times 2x squared plus 15x plus 9 to the power 99 times 4x plus 15. And this is your final answer. You can simplify if you want, but then it's fine. You can leave it like that, like this. Are we all together? Are we still together?
Hi, ma'am. I just have one question. Where did you get the 4x plus 15?
I differentiated this function.
Oh, okay. I didn't see that. But is it possible for you to maximize your screen, ma'am?
Nope, it's not possible.
But
I won't be able to write if.
Oh, okay, ma'am.
Yes.
Thank you.
Unless you guys want me to use slides. Not right.
No,
please.
Hello, ma'am.
No slides, ma'am, please.
To the power 100 given, how did we find it? 100 to the power, u to the power 100.
U to the power 100.
The dy, yes, that one.
This is what
y
we
is equals to.
differentiated. We differentiated y with respect to u. We used the power rule there, and this is what we obtained. Remember, you take n, you multiply with it, then you subtract 1 from the power, which is n, from n. Our n was 100, so that's why we have 100 u to the power 99 because we subtracted 1 from 100. Is it fine?
No, it's just that, okay, I wanted to find the y is equals to u to the power 100. Is that one a given, or how did we find it?
I introduced the new variable, which is u, because
Oh.
I wanted to use this rule. And that's why I had to make that function that we were given to be in this form. And this form is one variable to the power n. But our function was this function to the power n. So I had to let this function to be one variable. That's why I let this function to be u.
Right.
That's why now I have u to the power 100. Okay, just come here to your given function where there is this part, write one variable. Can we move on?
Yes.
Hello, ma'am.
Yes.
Is it possible that we can do the example that we did the last time?
I'm sorry. Okay, the thing is, I don't have the examples. If you guys can remind me, I always take them from my head.
Okay,
So-
okay, because it was only did one example. So I do understand today's example, but I'm not sure if I see it looks like we did it two different ways. So it was only one example of last time, and I think it's shorter than this.
Yes, it's shorter than this, but you guys last time you said you did not understand. That's why I had to explain step by step today. In fact, it's the similar way as I did last time. It's just that I was explaining everything step by step. Oh, you like how did we come up with the chain rule, and then why do we use it? But last time I just used the chain rule. But as you go, like as you do more examples, you'll notice that it's become shorter, because you know that the derivative will always be the derivative of the outer function times the derivative of a shorter function, right? Okay, for me, I can use that rule, but for you, I need to explain step by step so that you guys will understand. I don't see the reason of doing what I did last time, because when I did it, you guys said you don't understand it. I don't know. Which one, guys, do you prefer? This one or the other one last time?
This one. This one is very much shorter. This one.
This one.
Substitute you there.
Thank you. Okay, let's try and do another example where we'll be using another rule. Right. Okay. Suppose now you are given y equals ln 2x squared plus 15x plus 9. And you are asked to find the derivative. You are asked to find y prime, or you are asked to differentiate this function, find the derivative of this function, right? Okay. Again, it's not easy to differentiate this function just by looking at it, right? Like from the rules that we did not do a rule for differentiating a function like this. We only did a rule for differentiating function like y equals ln x, just one variable, right? But if you want to use the rule that's the rules for this function, okay, we first compare these two functions, right? They have the similarities between them. It's this ln of something and ln of something, but here we have a differential function. We just have a variable, we have a function. But we said okay, we know that to differentiate, we know how to differentiate this, because we said the derivative of this y prime will be 1 over x, right? Okay, for us to use this rule, please mute your mic. For us to use this rule, we need to write this as one variable, just one variable. Okay, and I'm going to name that variable u, which is the inner function. Okay, say u equals to x squared plus 15x plus 9, right? If this function is u, so this means our new function is y equals ln okay, this means our new function is y equals ln u, right? Okay, if we differentiate this function, the derivative of this function would be dy over du. Okay, the reason we have over du is because this function is in terms of u, right? This function depends on u, doesn't depend on x anymore. It depends on u, right? Okay. And if we differentiate this, we'll have 1 over u, right? Okay. But initially, we were asked to find dy over dx, right? And we know that the chain rule says dy over dx is equal to dy over du times du over dx, right? We have dy over du, which is this part. And we have a function, we have u, which is a function of x. So this means from here, we can differentiate this function with respect to x to solve for this, right? Okay. This means we'll have du over dx, which is 4x plus 15. And then we substitute this here and this here, okay? If we substitute this, we'll have dy over dx equals to 1 over u times 4x plus 15. But our original function did not have u, so this means we have to put back the value of u, which is 2x squared plus 15x plus 9. Okay, and another thing is how we can look at this. Dx of dy over dx, right, is equal to your y function from your y function. Okay, your y function it is in terms of u, right? So this means from here we'll find dy over du, right? But u has it is a function of another function. It has x as its function. So this means if we differentiate u, you'll have du over dx because u is a function of x. So this means our dy over dx is equal to dy over du times du over dx, right? Okay, this is how this thing works. Imagine you had maybe y is equal to 3u squared, but you are given that u is equal to maybe is equal to 2 w to the power 5, right? But again, you are given that w has another function which is x. Let's say w is equal to 2x, right? So if I ask you to find dy over dx, then your dy over dx would be equal to, you know that y is a function of u. So this means your dy over dx would be dy over du times, you know that u has another, is a function of w. So this means you have dy over dx times du over dw because y is a function of w, but w is a function of x. So this means you multiply this with the derivative of w with respect to x, right? Again, if you want to check if you'll get the same answer, if you are correct, right? You can write this as okay, I'll write this as dy over dx, dy over dx, and I'm left with this, right? So this means it's multiplied by this du over du times, then I'm left with this dw over dy times dw over dw. We know this is 1, right? And we know that this is 1 again. So 1 multiplied by 1 is 1. 1 multiplied by dy over dx is dy over dx. So this means we are correct. We can write the derivative of all these function of all these function is dy over du times du over w times dw over dx. That's why here, since we have y as a function of u and u as a function of x, that's why we have dy over du times du over dx, because this gives us 1, then we are left with dy over dx. So this means our formula that we used here, it's correct. Are you still with me?
Ma'am,
ma'am.
I have a question.
Yes, I'm listening. Hello?
Sorry, ma'am. So
when you get to that derivative of dy over dx, you don't need to simplify further. You can just leave it as 4x plus 15 over 2x to the power 2 plus 15x plus 9. So that is your answer in that solution, like in that function or the problem that you were given.
Okay, here there was no way we can simplify further.
Okay. Okay. So if we leave it here, then I think I do understand. Okay.
All right. Any more questions? Okay. Guess you guys, you don't have questions.
So sorry, ma'am.
Ma'am,
Will I be wrong? Let's say if I divide, let's say maybe I just take it further and then maybe just divide with 2x. Just divide, okay, how many 2x on 4x? Then I get it 2x plus 15. And then on my denominator, I get, let's say, x. What is that?
Are you answered?
Did you remove it? No, it's just in room. I just want to understand. Let's say I just take it further. I just dividing.
Dividing
Where is that?
by what?
Hmm. Can
What are you
you
going
scroll
to
down?
divide by? Pardon?
Can you scroll down? So, okay, someone just asked, is it okay if we just use, okay, you just mentioned that there's no way that we can simplify it any further. So, no, I was just saying maybe just ask how many, okay, if let's say just divide the 4x by 2x, then I'm left with just 2x, or maybe just 2 plus 15. Is it the 15, the other one? And then on the denominator, and then I'm left with x squared. It's just that I'm just looking at it. I'm not saying
Okay.
maybe we need to take it.
On top, what are you taking as a out as a common factor on top? We have 4x
It's a 2x
plus
2x
plus 15x. Okay.
Yes.
You have 4x plus 15. What are you taking out as a common factor here?
It's a 2x.
Okay, you take out 2x here. 2x, you'd be left with 2 because 2 times 2x is 4x, and then plus, what is 15 divided by 2x? Like if you take out 2x here, what are you going to be left with?
On my denominator, or on this 15.
Yes, on
Because
this
what I
15.
wanted to do is just that no, I wanted to leave, let's say maybe the 15 as is, and then on my denominator, and then I just take the 2x and then just leave the. Okay then.
Are you sure?
Maybe
Maybe
15x.
maybe if we had something like this, 4x squared plus maybe 16x over, let's say 16x squared plus maybe 18x. It was going to be easy for you to take out 2x or 4x because you know you can take out 2x here, you can take out 2x here. And again, from here, you can take out 2x. But since we have, my pen. Did it just stop writing?
All right. Otherwise, no, I understand what you just did.
Okay. Thank you.
Thank you so much.
Sorry, ma'am. Can I interject real quick? The only way what's the denominator actually works now, if you can use it on the top and at the bottom to what's name factorize it further. So if the top is uneven and the bottom is not, then you won't can simplify it further. That's the reason why you can't simplify it further.
And we have a new problem. My pen has stopped writing.
Can you double click that? Yeah, below head and the next
Close the
second.
header.
Yeah.
God. All right. We don't have questions anymore. Can move on. Okay. Guys, please
Sorry, ma'am,
try and
before you
attend
move
this
on,
one. Yes.
before you move on, I've tried to solve the one that you've just given us now, and then on the answer, I get 6 times 2 times 2x to the power 5. So do I multiply that 6 times 2 times 2 for the final answer?
Pardon?
I'm trying to solve the one with the y, u, and w. So on the last part of my answer, I get
Yeah. Oh, you mean the one that I was making just
but that you're making example for. Yeah, that one. I'm trying to solve that
Mhm.
one. And then on
Okay.
the final answer, can I give you my answer so that I can see if I need to simplify it further or where do I leave it? Can I give you the numbers to write so that you can assist
Yes.
me whether do I need to simplify it further? Okay.
Yes.
The answer that I get is
Okay, let's start by giving me this the original function. Y is equal to
3u squared.
3u squared. And then
And then
u
u is equal to w. A is equal to 2w to the power of 5.
w to the power 5. And then the other one,
The w is
w
2x. Is
2x. And
Yes.
then your answer is
Okay,
dy
the answer
over dx.
when I differentiate for y, for dy over du, I get 6u. And then
u.
for du
For
over
this one.
dw,
Mhm.
for that one. No, it's dy over du. That is 6u. And then
Yes,
for
Mhm.
du over dw, I get 10w to the power of 4. And then for dw over dx, I get 2. And then
Okay.
I went to simplify further to get rid of that w. And then I had on the next step I had 6. Sorry, I had 6, and then I had an open bracket 2w to the power of 5 because I substituted that w that we have on top. Yeah?
Remember, w is equal to 2x, right? So the next
Yeah.
step is to come here where there is w and substitute w with 2x. So
That
we
is my
have
next
2x
step
to the
that I've
power
got.
4 times 2. Right? Oh, you were substituting then
By
6 times 2 w to the power 5. You were substituting here.
yeah,
times
and then I got that step.
And then you substitute back the x. 2 times 2x to the power 5 times 10 2x to the power 4 times 2. And then we simplify this, we'll have, okay, 2 times this is 12 times 2x to the power 5. 10 times this is 20 times 2x to the power 4, right? Then you have 2 to the power 5, right? What is this? That's 8.
Is it not? Yeah.
Nolwazi,
That's
Nolwazi,
yeah.
can I ask something? Why are you still
Yes.
multiplying by 2 there at the end? If it's remember it's 10, why do you still have to multiply by 2?
This 2,
Like the
That's
function
10.
is 6u times 10 w over 4. Why do we still have to multiply by 2 after substituting everything in?
okay, remember here we said this will be dy over du times du over w times dw over dx. And this part, when we're differentiating, we said the answer is 2. Right, that's why we have 2 here. And then this part, it's this one. This one is this one. So that's why we are still multiplying with 2. Everything with 2. Because what we did from here to here was to substitute the value of the du, which is 2x, right? We didn't do anything to the values, the variables, other variables. We only substituted the value of w, which is 2x. That's why we still have 2, we still have 10, we still have 6. Is it fine?
Yeah, thank you. Yes.
Okay.
Nolwazi, the confusion that I'm getting now is I got it until to the third last step from you say from I got it to where we have 6 open bracket 2w to the power of 5 ne? Times 10 into 2 into a bracket of 2x times 2. And then I got to the step following that, which is 6 times 2. Okay, it's the second two last steps that I don't, that you got me lost in, where we have 12 into 2 to the power of 2x.
Oh, I said 6 times 2 is 12.
Okay. Okay.
Then I took this down, like, right? Then I said 2 times 10. And then I took this one down again.
No, I understand. It's the last 2 that you've multiplied that 10 with.
Then I said 2 to the power 5, it's 32. X to the power 5 is x to the power 5. Then I took this 20 down, this 12 down. 2 to the power 4, it's 16. X to the power 4 is 4, right? Then we have 12 times 32. 12 times 32, what is that? It's 384. X to the power 5. We're coming back with it. Then we have 20 times 16. What is 20 times 16? That is
320.
320. X to the power 4, right? This will give us 9, right? So we have 384 times 320. 122,880. Then this will give us x to the power 9. Because the bases are the same, you add the exponent. Then this will be your final answer if you want to simplify it further. This, you have to end here.
Thank you, Nolwazi.
Hello, ma'am. Can I please ask?
I'm
Hello.
listening.
Can you please scroll up a bit? I just want to see the dy over dx equals to, what did you say there? on the formula. Just scroll up a bit.
The chain rule.
Yes. You said it's dy over dx equals to dy what? Not that one, the one that we are doing right now. The one that we are doing right now on the example. On the example that the lady just gave you, I just want to see the formula. How did you do it?
Yeah. Dy over du times du over del u times
Sorry,
del u over dx.
You break. I couldn't hear you clearly. It's okay. Du y over dx.
Yeah. Can you
equals
see my
to-
screen?
Yeah.
Can you? Yes. Then take it from there.
So it's dy over du. What? After the equal sign. After the equal sign is dy over d.
It's dy over dx times du over.
Better
du.
you explain the chain rule to him, all of it, because he is kind of lost.
And I just wanna see if I made it. I'm able
Guys,
to write this. It's dy over
wait,
d.
before you're right, guys, I gave you a task last time. You had the whole weekend. I said, please go and look at the chain rule so that when I teach it again, it will be easy for you guys to understand. It seems like no one of you bothered to check it. None of you.
No, I just wanted to see because I couldn't see if it's dy over du or is du over dy just after the equal sign.
No, I'm not talking to just you. I'm talking to everyone.
Sorry. What I was emphasizing is that it will be better for you to explain him the whole chain rule, because he was going to ask like 1, 1, 1, 1, 1, and I can see that he doesn't understand the whole chain rule. That's why I wanted you just to explain to him so that you will be clarifying to everyone who was having the very same question that he was asking, because I think it's irrelevant because it's the exercise that we're doing right now, not something else. I don't know what others are saying.
I understand, ma'am. I'm not gonna lie.
Hi, ma'am. Can we move on? Because
It's really breaking, guys, because like I'm even giving you guys 2 classes. You guys are supposed to have 1 class. I had to fight with the lady who's teaching DSC 1630 because I'm taking two slots. Everyone is taking 1 slot. The least you can do, the least you can do is to meet me halfway. Is it
Hi,
too much to
ma'am.
ask? Yes, hi.
Don't get us wrong, ma'am. We're here the first task. Even today, we are here. We're just trying to understand, and we do understand, even if we may be quiet and others are asking here and there. But trust us, you did not waste the last time you taught us.
No problem. Guys, I'm gonna give you 3 minutes. Please try and attempt this. Okay, find dy over dx. We'll do it together in after 2 minutes, but please do try it.
Hi, ma'am. The last time you gave us something like this, but it did not have the +9 in the end. So we should try this one now, right?
Yes, now. The ones I always give you guys is just the extra exercises.
Yeah, can you show that screen again, ma'am? I'm still writing it down.
Sorry, ma'am, may you scroll up a little bit? I just want to check my answer. Just the final answer.
Pardon?
May you scroll up a little bit, ma'am? I just want to see my final answer. Check my final answer.
Yeah. Oh, you're still doing this one? Yes.
Yes, ma'am.
Okay. You want to check from just the last answer or the final answer or the steps
Just the
to.
last answer, the final answer.
All right.
Thank you.
Because you are muted. I'm not sure what's going on, but I'm not hearing anything.
I was not saying anything.
Okay, thank you.
Did we all get this answer? Yes, no.
Yes, ma'am.
Yes, yes, we did.
Yes, we did.
Anyone with a
Yes,
different
ma'am.
answer? Mhm. Anyone with a different answer?
Yes. Where there's 2x, where there's 4x, I have 2.
You have 2x.
Yes.
Okay. Anyone with a different answer again?
Okay,
Another
ma'am, can I
answer?
ask?
Can I ask something?
I have a
Can I
different
ask something,
answer.
Lwazi? If
Yes.
if I have e to the power 2x, if I have e at the beginning of the answer, will I be wrong or will I still be correct?
Right. You have this part here and this part here.
I have them swapped around. Will I still be
Yes,
correct?
it's one and the same thing.
Okay, thank you.
Ma'am, can you hear me?
Yes.
Okay, so don't we derive the 4x plus 15? Because I got 4e to the power of 2x squared plus 15x plus 9.
You got 4e.
4e to the power of 2x squared plus 15x plus 9.
Only this part.
Yes, to x squared plus 15, yes.
Anyone with a different answer? Okay, let's assume we all got this straight. N of this straight. Okay. First, we said y is equal to e to the power 2x squared. This means your mic plus 15x plus 9, right? And last time I gave you a rule to differentiate y equals e to the power x, and I said the derivative of this would be e to the power x, only if this is just one variable. But here we have a function instead of one variable. But for us to be able to use this rule, we can just let this function to be one variable. So that's why we have to introduce u. You have to introduce u and have u equal to 2x squared plus 15x plus 9, right? If u is this, so this means we have a new function called y equals e to the power u, right? Okay, and then remember we are asked to find dy over dx, right? But here, okay, we are asked to find dy over dx, and y it's a function of u, but u is a function of another variable. So dy over dx would equal to dy over du, because y is a function of u, but u is a function of another variable, which is x. So we'll have dy over du times du over dx, right? Okay, we can find these parts by differentiating this function and this part by differentiating this function. Okay, if we differentiate this function dy over du, we said we'll obtain e to the power u, right? And if we differentiate this function du over dx, we'll get 4x plus 15, and then we substitute these two back here, right? We substitute this and this, you will have equals e to the power u times 4x plus 15, right? But your function was not in terms of u, so we need to substitute the value of u we introduced you with. So this means if we put back the value of u, we have dy over dx equals e to the power 2x squared plus 9x plus 15 times 4x plus 15, right? Which is the
Isn't
same
it
thing as this one. And
it's
there
it
is a
15x plus 9,
I
not
started with
9x.
4x plus 15 e to the power 2x squared plus 9x plus 15. The reason I wrote it this way is because I think it looks neater. There was a question?
I was
Was
saying,
there a
is
question?
it not 15x plus 9, not 9x plus 15?
Oh, yeah. Thank you. 15x plus 9. 15x plus 9. Thank you. Do we have any more questions? Yes, no?
No more questions, ma'am.
No
No
question, ma'am. Everything is clear.
question.
All right, thank you. Um, oh, this ends here, then plus 10 plus 9x. Yeah. And she may offer.
Sorry, ma'am, can I just ask, is the plus e to the power, is that on the under the what's the name part of the fraction, or is it on the outside of the fraction? The one you just wrote now.
The other side of the fraction. We can do one together here, and then we'll do the rest.
Sorry, Miss Nkomo. The second one,
Yes.
is it e to 10x squared plus 9x?
Yes.
Okay, thank you.
Please mute your mic. Okay, which one do you guys want us to do together?
The first one, ma'am.
The last
Yeah,
one.
I second. Let's do the first one.
The first one, please.
The first one. The first one or the last
Yes.
one?
The first one, please.
The first one.
First one.
This one you can do.
You can do the fourth one.
Yes.
Uh,
Yeah, the first one we will try it on our own.
Yes.
The
But
fourth
first
one.
Yeah, the first one seems complicated. Can we do the first one?
You sure you want the first one?
Yes.
Yes. You want the first one, ma'am.
No, the first one is easy. The fourth one.
The fourth one is the most difficult one. Ma.
No, the first one is easy because it has a plus sign there. We rather do the fourth one.
The fourth one has three functions. It's the function that has ln, then the function that has to the power hundreds.
Even the second one has the
That,
three
that has
functions.
10x squared plus 9x. But that
Yeah.
one is easy. Because you know you can let one variable to be this. If you let this one variable to be this, then you see you still have the same thing here and here. Then that means you have ln times this, ln of this times e to the power the variable. That means you have a product, right? But here, this you know that 1 over x is the same thing as x to the power minus 1, right? So this means 1 over 3x squared, it's the same thing as 3x squared to the power minus 1, right? So this means here you can write this as 10x squared plus 9x to the power minus 1, then plus this function. Then you can use your substitution again. You let u to be this, you let u to be this, right? Do you still want me to do this one, even after giving you the hint?
I've changed my mind now.
Miss Nkoma,
Yeah,
can I
after
see
this
the rule
discussion, I'm clear
again?
now.
The what?
The 1 over x rules. Can I see the last part? Okay,
No,
thank you.
After your explanation, Miss Nkomo, no, I've changed my mind now. Let's do number 4. Sorry, Miss Nkomo.
Yes.
Miss Nkomo, can you hear me?
Yes.
Hello. Okay, and
Yes,
number
I
2.
can hear you.
Okay, number 2 it's ln 10x squared plus 9x in brackets. Then it's e to the power 10x squared plus. I can't see what is that.
9x. It's 9x.
Oh, it's 9x.
Yes.
Thank you.
Operations management.
Okay, I'm going to do this one, right? Okay, if we let u to be 10x plus 9x, we'll have something like this. Y equals lim u to the power 100, right? But still, you cannot integrate or differentiate this directly. So we can let this u to the power 100 to be another function. Let's say we let v to be u to the power 100, right? So this means our function is simple now, because our function is now y of lim v, right? Okay. We want to find dy over dx, right? But our y is a function of u. So this means here we'll find dy over dv, right? But v is a function of another variable, which is u. So this means if we differentiate this, we'll find dv over du. U, it's a function of another function, which is x. And if you differentiate, so this means if you differentiate u, you'll find du over dx, right? Then the next step is to come here, you find this derivative, you find this one, and then you find this one, and then you substitute them back here. You simplify if you have to simplify. If there is no need to simplify, then you take the values of be in terms of x rather than in terms of u and v. So your final answer must be in terms of x at the end. Because, for example, if we differentiate this, you'll have lim v, you'll have 1 over v. Then this means here you have 1 over v. Already you have v, which you don't need in your final answer. But you know that v is equal to u to the power 100, right? Okay, let's do this. You'll have 1 over v, right? Then you want to find dv over du. You'll find it here. If you differentiate this, you'll have 100 u to the power 99, right? So this means it's times 100 u 99 times du over dx. du over dx, if you differentiate this with respect to x, you have 20x plus 9, right? Yes. Okay. This is the answer after substituting the derivative of this derivative and this derivative and this derivative. Then the next part is to substitute this variable, these ones, right? First, let's substitute v. Remember we said v is equal to u to the power 100, right? So this means we have 1 over u to the power 100 times 100 u to the power 99 times 20x plus 9, right? But we still have a variable u, and we know that a variable u is equal to this function. So the next step is to take this function and substitute back here where there is u, and that would be your final answer. Do we have questions?
Yes, ma'am. Can we simplify it further, or can we leave it as that as our answer? If in exams, if it shows that answer in the multiple choice and others, we just have to choose this one. Do we have to go further?
If this answer is there, then you can choose it. If it's not there, you have to simplify it further. Or unless you did something wrong in your calculations, then it won't be there. Did I answer you?
Yes, thank you, ma'am. Sorry for I was writing.
Thank you. Do we still have questions, or we have to end here?
Ms. Ngomo?
Yes.
So we still yet to do the application.
Yes.
Okay, that's what we're gonna start with on the next class now.
Yes.
Okay.
The reason I kept on delaying the application is that if you guys